Hello, everyone. Welcome to our Oracle AI database series that will be taking place every first Monday of the month at 10 a.m. Standard Pacific Time, unless it falls on a public holiday. This session explores Oracle's AI database knowledge graph capabilities, showing how to analyze relationships with data using SQL and natural language to create, query, and visualize graphs, run pre-built analytics, and leverage connections for smarter decision making across diverse use cases. Now, I would like to introduce Melly and Raul as our main presenters. Over to you, Melly.
So what we will do in this session is we'll start from the basics about what's a graph, and we'll go into knowledge graphs. So you might have been hearing of the term knowledge graphs lately, particularly in the context of AI. And then we'll go through two use cases. As Stan said, we're trying to cover diverse use cases. One, we will use graph analytics to find bank accounts that could be engaging in fraudulent behavior. And then we'll use graphs to represent content in a document and then answer questions about that document when you ask queries in natural language. And in our demos today, we'll use autonomous database, but please note that the graph feature and everything we're talking about today is available in any supported database. So we're all used to the rows and columns format where we organize data in rows and columns, be it Excel spreadsheets or relational tables and so on. What graphs help you do is represent your data as things in your data, that is known as the entities, and the relationships between them. And we'll look at a few examples. So rather than look at data as rows and columns, we look at data as things and how these things are connected to each other. So this for some terminology. You have nodes, also known as a vertex, and then edge, also known as connections or relationships. And as I was saying, nodes or vertices represent things in the data, and edges represent the relationship between them. And here are a few examples. If you have a database of, let's say, your customers in something like a payment solutions app, where now you can say that every customer is a node or an entity in your data, and when one customer transfers money to another customer, that's the relationship between them, and that's the edge. And you can have, let's say, Mary knows Jane, so these are two customers, and they're connected with a relationship that Mary knows Jane. You have another thing in your data, another type of entity, which is an object. That's a laptop, and that's what Jane bought. So you have Mary knows Jane, and she bought a laptop. And then here, the final example is you have, let's say, IP addresses represented by nodes in your data, and then network traffic between them. So when a network packet goes from one IP address to another, that's the relationship between them. So pretty much any data set can be represented as a graph. And the reason to do so is it helps you ask different questions of your data, helps you run analytics based on graph algorithms that provide new insights into your data that are difficult to do when data is stored only in the row and column format. So the primary the early user, I should say, the early user of graph technologies have been financial services customers, because they're looking to use graphs to kind of track the flow of money. So bank accounts become, when they represent the data as a graph, bank accounts become nodes in a graph, and every time there's money moving between accounts, that becomes a relationship between those accounts. So then you can start looking at answering questions such as, has money moved around in a cycle? Like, has money moved from account 1 to 673 to 730 and back? And so on. So are there such cycles in the graph, which for them is suspicious? Or are there other anomalous patterns that they're looking for? So they're able to see how money flows. Similarly, you have examples of using graphs to model software systems, then you're looking at how data flows between different entities and so on. So relationships can be many different kinds. And then you can ask new questions of your data. For instance, here you can say, how many cycles do I have, or cycles of money do I have that start and end in this particular person's account? Here I have two accounts, 387 and 934, and which are all the different ways in which 934 and 384 are connected. So continuing with the financial services theme, we would be saying that, okay, here is money moving from 934 to 387 using multiple different types of paths. So 934 transfers money to 651, to 824, to 387, and so on. So they can follow the path of money or data, whatever relationship you're looking at. Graphs are also very helpful in identifying communities. These are nodes in the graph that are more tightly connected to each other than they are to the rest of the graph. And then graph algorithms you can run once you model your data as a graph to get insights like this, like the different communities here. So till recently, of course, we were all writing code, and we wanted to. Oracle was worked with the SQL Standards Committee to come up with the syntax to write graph queries. Like, do you want to represent cycles? You want to find anomalous patterns? If you want to ask such queries of your data, you need the syntax to be able to specify it in a query language. And for the Oracle database, SQL is always the language of choice, at least where we have all our features, and then you have other drivers like Python drivers and so on. So we work with the SQL Standards Committee to add SQL syntax for specifying graph patterns. Like here you see this pattern is saying find me all paths that are 4 hops long, starting from V1 and ending in any account. You can now ask the same question in a natural language, and there are ways to just translate that into a graph query using an LLM or using a select AI infrastructure to translate that into a query that runs in SQL. Oh, sorry. And then we also have algorithms that use the Python or the Java API. And we have over 80 pre-built algorithms available that you can run like PageRank that helps you find important nodes in a graph, as in which are the nodes which have a lot of transactions flowing through them. And then graph machine learning algorithms to find patterns. And I'll be showing an example of these two algorithms. So a note on graph versus knowledge graph before I go into the demo. So any data modeled as entities and the connections or relationships between them is a graph. So as I was saying, any data can be represented as a graph. I think of a knowledge graph as a specific type of graph, which is connecting real world concepts and relationships between them. Like in the bank example, the financial services institution example, I had this graph representing transactions, and it goes right down to the data, right? This account transfers money to this account and so on. In the knowledge graph world, you can say things like, this is like, I work for Oracle. So Oracle is a company, and that's a real world concept. Someone being an employee of a company is a real world concept. So a graph that represents such concepts rather than like the bits that make up data, a graph that represents concepts is known as a knowledge graph. And this term is getting a lot of interest in the AI era. And nowadays, these terms are used interchangeably. I would say people refer to any graph as a knowledge graph and so on. There's a lot of confusion out there. When it comes to a knowledge graph, it can be either stored as a property graph or an RDF graph. I won't go into the distinctions between these models. I'll just say that the property graph is considered the simple and flexible model, and RDF graph is more sophisticated in terms of capturing semantics about how data is connected. I just want to say that the Oracle database supports both models, both the property graph model and the RDF graph model. So once again, looking at graph versus knowledge graphs, on the left, we have these bank transactions. And on the right, we have a knowledge graph example, where here you have Einstein, and Rahul is going to be using this in his demo. You have Einstein, and from his Wikipedia page, we can see that Einstein contributed to quantum theory. He developed the theory of relativity. He was born in Germany. So you can see how this graph is different from a band graph, and that's the difference between a graph and a knowledge graph. And the nice thing about graphs is it makes it really easy to add new facts. So let's say we had all these facts about Einstein, and this year in 2025, John Clark was one of the co-winners of the Nobel Peace Prize. Nobel Prize in Physics, I'm sorry, not the Nobel Prize in Physics. So you can add this fact here that John Clark won the Nobel Prize in Physics, and this is a common node between John Clark and Einstein, and this is the node that connects them. And then you can have some other facts about John Clark. He was born in the United Kingdom. And then you can automatically derive information like, oh, okay, United Kingdom and Germany are both located in Europe. So you can find new real-world facts from existing facts in a graph. And John Clark worked on quantum mechanics. And you can say that, oh, okay, these are actually similar, and they're the similar area of work. So here's another similarity between John Clark and Einstein. So a knowledge graph helps you add new facts easily to a graph, link different graphs, and deduce new relationships in your data. So the graph feature on Oracle AI database is a native feature of the database. This means that all features for security, scalability, availability, all of those apply to the graph feature. And another key feature is when we create a graph, the graph is like a view on your data. We don't copy data. We don't move the data to separate space. You can if you want to, but you don't have to. So all inserts, updates, and deletes that happen in your data are instantly reflected in the graph because it's like a graph view of data. So it's well suited for operational workloads. And many graph vendors don't have this advantage, or they have a lag time when they're synchronizing the graph with the base data, and we don't have that. And for the running queries, as I was explaining, you can use SQL syntax from the 2023 SQL standard. So in preparation for the demo, let's look at this bank graph again. So I have a bank accounts table and a bank transactions transfers table. And then how do I create a graph from this information? Because the information of what is connected to what is embedded in the tables, like one is transferring money to 673, 673 is transferring money to 730, and so on. But it's hard to ask queries, and it's not intuitive when that connection information is buried in tables. Whereas when you represent that same data as a graph, you get it's more intuitive for you to ask some of these questions. So in code, if you have to do this in code, and I'll show you how to use a tool shortly. If you're going to use this in code, here's how you would get the graph representation of data by listing which are the vertex tables or the node tables and which are the edge tables that represent the relationships. So this is a simple example of only one table each, but you can have a more complex example. And here is a set of tables that connect a product, the components a product is made up of, the categories a product belongs to, and then the components that a product is made of, and then the suppliers that are supplying these components. And you can have a multiple level hierarchy here. You can say product has component, which is subcomponent, which is subcomponent, and then you can go to the supplier. So you have these tables, and they all have a relationship between them based on what is connected to what. And you would, if you were to create a graph in code, it would look something like this. You're listing multiple vertex tables and multiple edge tables. And nowadays with tools or AI, you don't have to really look at this code, but developers in the audience would like to actually know what's happening behind the scenes. And then finally, you can create a knowledge graph from documents or text. So you can create a knowledge graph from tables. We've invested a lot in supporting that. You can also create a knowledge graph from this unstructured data. And Rahul will be demonstrating how he did that. So there are many different ways you can get your graph so that you're surfacing the relationships in the entities in your data. So for the first demo where I'm finding bank account that could be engaged in fraudulent behavior, I will start with, okay, saying that we know that 934 is a fraudulent account. Which other accounts have a similar money transfer pattern? Like if 934 has three cycles connected to it, three money movement cycles connected to it, we want to see which other accounts have a similar pattern because they're probably engaged in similar behavior. So in the demo, we'll show how you can create a graph from bank transaction data. Load the graph into graph server, which is a specialized high-speed server for running algorithms. And then we'll run the graph machine learning algorithm, deepwalk. So let's now create a graph from this. And this is syntax. Sorry, this just repeated a couple of slides. Let me go into the demo right now. So we looked, so these are the two tables we have, bank accounts table and bank transfers table. And this is where I said I'm having trouble connecting to the database. I'm just going to scroll past that. So this is the create property graph statement. If I were to do this using our modeling tool, I can go to the graphs page. And actually, you know what? I'm going to have trouble with the database connection. I'm really sincerely sorry about that. So let me just, I think I'll skip the more. Let me just state that we have a tool to automate creation of a graph from tables. And now I will go back to my notebook that I'm showing right now and hope that I can get through this without too many errors. Okay, so once we've loaded this, once we've created the graph, you can run a graph query like this. This is just saying I'm selecting all rows from this bank graph where source is connected to any destination. So any source account is connected to any destination. So it's like a select star from tab. And you would get something like this. You're selecting all the nodes and all the vertices essentially in the graph. So now to make sense of this graph, we have to start writing queries, either in SQL syntax or maybe perhaps in natural language. I'm going to show SQL syntax here. I'm first loading this graph into graph server. I don't need to do that for graph queries. I just need to do that for running graph algorithms. So if I were to run a query like this, which says, find me all nodes in the graph. Oh, sorry about that. Find me all nodes in the graph where we start with this particular account, and they are 1 to 4 hop cycles. So you see here I have a variable source and I have an ending variable source. That means I want this path to start and end in the same account. And I have this 4 to say that this is 4 hops long. So this is the graph syntax that is part of SQL 2023 and now part of Oracle AI database. So when you run the query, you would get something like this. You have Russell and all these cycles that are kind of connected to this particular account. So something like that. Okay. So now let's run the algorithm PageRank. And as I mentioned, these algorithms are pre-built. You just have to call the API to run the algorithm. And once I do that, each graph has an extra value associated with each node that gives you the relative importance of that node. And we can see here that these are the top nodes that have a higher PageRank value. And Russell Rivera is fourth on the list, and we're already looking at him. So maybe he needs to be looked at more closely because we're already suspicious about his activities from other queries that we've been running. And here, I'm running the same query that I ran above, like find me all 4 hop cycles between the start and end with Russell Rivera. And but the difference is I have run the PageRank algorithm and I have an additional information that I want when I visually look at the graph, which is to tell me which are the nodes with a high PageRank value. So not only am I just looking at how many cycles start and end with Russell Rivera, I want to see which one of those are highly connected as well, because which one of them have a high PageRank value. These types of questions are very difficult to answer in a row and column format. So some other queries we're running here, instead of asking for cycles, I'm just saying find me all paths 3 hops away from this particular source name. So let me go over to running a graph machine learning algorithm. So if we say we have reason to suspect Russell Rivera's account is account 934, I want to build a model that will help me identify other nodes which have similar patterns. So we build a model, we create the model, we train the model. And after training the model, you can say, you can run, and this is the deep-walk algorithm. What the deep-walk algorithm does is, from each node in the graph, it finds all nodes that are reachable from that particular node. So it kind of does a reachability analysis and traverses each path that can be reached from a particular node, and that's basically the deep walk algorithm. And then, uh, so once you do that, you can then you can say that, okay, I want to find all accounts that have a pattern similar to 934, and of course 934 is similar to itself. And then you see the 387 and 135 also have a high value. So if you were to visualize a graph using queries that include 934 and also 387 and 135, which we have identified to have similar fraudulent patterns, you can see here that you get similar patterns. Like you see, you have this fan out kind of structure that you have in the pattern that's similar for all three accounts, which is why they had a high value when they were running the deep walk machine learning algorithm to identify a model and fit them into the model. So with that, I will turn over to Rahul.
Like Melly said, one use case is that's often used for knowledge graphs is using machine learning algorithms and graph analytics. Another use case that we see used very often is representing unstructured data as a graph to answer questions typically about documents. So what I'm going to walk through in this demo is how we can extract entities and relationships from unstructured text. We can use those extracted entities and relationships to create a graph. And then using that knowledge graph, ask questions in natural language about the content of the text and get those answers back in natural language as well. So the way that we'll do that is we'll take Albert Einstein's Wikipedia page, and then we will convert that into a graph that we can then use for a document search. So like Melly said, the way that we create graphs in the Oracle database is by using tables to represent the nodes and the edges. So what we'll do is we'll extract the nodes and relationships from the text. Then we'll store those in our tables. So we'll have a vertex table and an edge table. We'll have our create property graph statement that will convert that document basically into a knowledge graph that we can then use to query in natural language. So with that, I will hop into the demo. Before I do, I'll just say that this is what I would call a schema flexible graph. So as we add new kinds of labels or new types of vertices and edges, they all get kind of put into the same edge table, so we can query them a little bit more flexibly. This is commonly something that might be used in document search, among other use cases. But with that, I'll hop into a brief demo, and I've made a video that we can run through. So basically, in this demo, what we're going to do is we're going to upload our document. So this is using Albert Einstein's Wikipedia page. In the background, what this is doing is sending that document to an LLM. In this case, I'm using the Oracle Generative AI service. And then it's creating a graph based on what we have in there. And we could run a query. So in this case, we're asking what are Albert Einstein's accomplishments? And so just with some light prompting or depending on how or using our select AI integration, you can get a generated graph query like we have here. And then this, when it's executed against the database, we can see our raw results. And then finally, we can send the initial user prompt and the results back to the LLM to get an LLM generated answer, right? So basically, if you notice here um, in these raw results, when we extract these entities and relationships from text and create a graph from it, we can essentially maintain like the semantics of each sentence. So, for example, we have here uh, Einstein developed the theory of relativity, right? So that's like a full sentence in itself. So the way I like to think about graphs is that they lend itself very well to kind of extracting these entities and relationships, creating a knowledge graph, uh, and maintaining, kind of that sentence structure through those relationships. So once we have, our LLM generated answer, we can actually add to the graph, like Melly said. So this can be useful for combining a number of different documents or just adding facts to our graph. So in this case, we added a question. We added, what is Einstein like, or that he likes pizza. And when we ask um, our application, it will generate our graph query, we'll get our raw results, and we'll get our LLM generated answer that Einstein likes pizza. So this is something that we can use, for combining different knowledge-based documents, so like PDFs, as well as, just for adding different facts as they come up. Okay. And so with that, I want to point you guys to a couple different resources that you can use. So the first two at the top are using kind of that domain knowledge that Melly mentioned. So using, property graphs with that bank transactions data set or one of our other data sets to, model and create a graph and run some graph analytics. And if you wanted to kind of run through a document search scenario, you can check out the live lab that we have listed at the bottom that runs through extracting, these entities and relationships from a Sherlock Holmes story. So you can just head over to livelabs.oracle.com and search for graph. All of our live labs and workshops are available for you there. Okay. And so with that, I will hand it over to Ernesto.
Thank you, Millie and Raul, for an awesome session. We really appreciate your time and help. I hope this was a good learning experience for everyone. If you want to learn more, here you will find a few links that will help you walk through Oracle Cloud, get hands-on experience. There's some detailed communication, our Live Labs website as well, and Oracle Learning Library videos on YouTube. And once again, you'll have access to the decks and links on our Day One and Beyond page, as well as Oracle Cloud Customer Connect. So what about training for your organization? If you enjoyed this session and you would like to conduct personalized training sessions for your organization, do email us at our personal training email, and we will reach out to you. If you want to conduct just hands-on labs, we have our newly designed Quick Shot Live Labs program for a more expedited hands-on learning experience for specific cloud topics. And under the Code Innovate program, we co-develop a solution based on your own use case. Please remember that personal training is an Oracle investment we make in our customers to help them grow and develop their OCI skills at no extra cost to them. Next slide, please. And one more. Okay, and this here is our Day One and Beyond series and upcoming sessions for the month of this is November, I'm sorry. You still have an opportunity to attend a couple more sessions this month with our hands-on series, our cloud security series, our core series, and did you know what's new in OCI? Now, our next database session will be on December 1st. In this session, you will learn how to enable microservices with Oracle's AI database.
So first question was, can we apply graph RAG concept for a typical customer service agent?
Okay.
Yeah, I can answer that. So this is a very common use case, I would say, for graph RAG. So for context, the way that I'm kind of imagining this is more as a customer service chatbot. And so for that, you can definitely combine different knowledge base articles or documentation into a graph. The way that you would do that is you kind of have two approaches. One is by using kind of that same scenario that I mentioned by extracting the entities and relationships from every document and then storing that as a graph. Another is to kind of chunk those documents, extract facts from the different chunks, and then run a vector search. And then along with that vector search, run a graph search to find the related entities, facts, and chunks to make sure that there's no context missing going to the LLM. So basically, the answer is yes. And the goal would be to enhance a vector search or to use purely a graph search, depending on your use case and what you find works best.
Thank you, Rahul. Second question is, are there any demo sites where we can get some hands-on? So I know that we have our Live Labs platform where you can log into that. There are some lot of free labs out there that you can try out. Some of those buttons provide you sandbox environment also in the form of a green button. So go ahead and go to livelabs.oracle.com and see what you can find over there and get some hands-on. But in terms of demo, do we have any recorded demos anywhere, Rahul or Melly?
I was just saying we do have a YouTube page which maybe has demos, or not just only demos, but demo short sessions and so on.
Okay.
But if you want to play with it yourself, then Live Labs is the best option.
We have two open questions. One is, a graph is ultimately stored as a table in a computer. So does a graph contribute to any access optimizations, or is it only good for knowledge visualization?
So it does, it's a good question, and it does contribute to access optimizations. And so one is you have the new syntax, which lets you write some of these data access patterns more easily. If you were to write that without the graph syntax, without the graph object, it would be quite complicated. And also internally, to support the graph object, we have some optimizations to make some of those traversals more efficient. So there's definitely an advantage over and above visualization. So visualization is definitely helpful, right? But there's definitely a query advantage in the sense of helping you write complex queries more easily, helping you write queries which you would not have been able to write at all, and also helping run those graph queries more efficiently.
Thank you, Melly.
And I'll add two things to what Melly said. One is that algorithms. So graph algorithms, kind of require that your data is structured as a graph. So, if you don't have your graph, you won't be able to run like a PageRank or a deep walk algorithm like Melly did. And the second is that you can run these pattern matching queries without knowing what table is related to a particular vertex or node, right? So if you have multiple different types of nodes, you can grab these related entities or objects without knowing exactly what what the table is. So kind of simplifying even more.
Awesome. Thank you, Rahul. Next question is, how do I get the graph, which data type to be used from the third-party application?
Yeah, I would just say that a graph doesn't use a specific data type. It's more of a data model. So you just write that create property graph statement, and it will kind of create this graph view on those relational tables using any of the data types that are supported by the Oracle database.
So thank you, Melly. Thank you, Rahul. And thanks everyone for joining the session.